Imagine waking up one morning, grabbing your coffee, and heading upstairs only to realize you're now aging slightly slower than your roommate downstairs. Sound ridiculous? Well, welcome to the weird world of time dilation. It's not science fiction, it's Einstein-approved physics. Time dilation means time can actually tick at different rates, depending on how fast you are moving, or how close you are to something massive like Earth itself. And scientists have proven this, not in deep space, but right here on Earth. We're talking height differences of less than half a millimeter, making time tick differently. So, what if this strange effect didn't just happen in nanoseconds but in minutes, hours, maybe years? What if time dilation became something we could see and feel every single day? Hold on to your clocks. We're about to stretch time like never before. Part 1. What exactly is time dilation? Let's rewind the clock a bit back to the early 1900s. Albert Einstein, a patent clerk with a wild imagination, started asking dangerous questions. Like, what happens to time if you're traveling near the speed of light? Spoiler alert, it slows down. A lot. Welcome to the mind-bending concept known as time dilation. In simple terms, time dilation is what happens when time doesn't tick the same for everyone. According to Einstein's theory of relativity, if you're moving really fast, like approaching 670 million miles per hour fast, or you're chilling near something incredibly massive like a black hole, time will literally slow down for you compared to someone else in a calmer, slow spot. But before you start sprinting laps to become immortal, know this. You'd need to run at near light speed to notice any difference. Good luck clocking that on your Fitbit. Let's break it down. Imagine you're holding a flashlight and you shine it. Light zips away at 186,000 miles per second. Now, if you hop on a spaceship traveling half that speed and shine the same flashlight. Here's the crazy part, the light still moves at 186,000 miles per second. That's because the speed of light never changes, no matter what. So to make that math work, the only thing left to give is time. So your time, your heartbeat, your thoughts, your aging all start ticking slower compared to folks back home. And that's time dilation. It's not just a theory either. We've measured it. Astronauts on the International Space Station, zooming around Earth at 17,000 miles per hour, actually experience time a teensy bit slower than we do down here. By the time they land, they're a few milliseconds younger than us. Congrats, space travelers, you're time travelers too. And that's just motion. Get close to something supermassive like a neutron star and gravitational time dilation kicks in. Same effect. Time slows. Physics gets funky. Your watch ticks differently. Your whole existence shifts. So yeah, time dilation is very real. It's not magic. It's not a sci-fi trick. It's just the universe playing with the clock. Before we bend time like cosmic spaghetti, don't forget to like, subscribe, and smash that notification bell. Around here, we can't slow time down, but we can make it way more fun. Part 2. When theory becomes reality. So you've wrapped your head around time dilation, the idea that time doesn't flow at a universal pace. Cool concept, right? But here's the kicker. It's not just something happening to astronauts or distant galaxies. It's happening right here, right now, on Earth, and scientists have the receipts. Let's start with one of the most mind-blowing experiments to date. In 2022, researchers at the National Institute of Standards and Technology, NIST, along with the University of Colorado Boulder, ran an experiment so precise, it could have been done by a Swiss watchmaker with a PhD in quantum physics. They took two optical lattice atomic clocks, the most accurate timekeepers humans have ever built, and placed them just 1 millimeter apart. That's about the thickness of a credit card. And guess what? The clock that was just slightly higher ticked faster than the one below it. Seriously, a 1 millimeter height difference created a measurable difference in time. Einstein would have danced in his socks if you were alive to see it. Think about that for a second. You could be standing in your kitchen, holding a spoon in one hand and the bowl in the other, and the spoon might be aging faster than the bowl. That's how sensitive time is to gravitational time dilation. It means even Earth's relatively modest gravity is bending time in measurable ways. Now, let's zoom out literally. Astronauts aboard the International Space Station are orbiting Earth at about 17,500 miles per hour. Between their speed, special relativity, and their altitude, general relativity, they experience time differently from folks on Earth. NASA actually had to correct for this when building the GPS system. Yep, your phone knows where you are because we account for time dilation. Without it, your location would be off by several miles. And the tech is getting wild. Today's next-gen optical clocks are so accurate they can detect a time difference by simply raising one by less than an inch. That's not science fiction, that's lab-tested, peer-reviewed reality. But wait, it gets better. Some scientists are working on using falling atoms in a vacuum chamber to measure time dilation with even more precision. Think of it as a free-fall clock. As atoms drop, their internal rhythms change just slightly because of gravity. We're literally measuring the flow of time by watching particles fall in slow motion. You can't make this stuff up. So yeah, time dilation isn't just real, it's happening to you right now. Your head is aging faster than your feet. If you live in Denver, you're aging faster than someone in Death Valley. And if you ever needed an excuse to take the elevator instead of the stairs, congrats, science just gave you one. Time isn't just money. It's altitude, it's motion, it's gravity, and now, it's measurable on Earth. Part 3. What if time dilation was obvious? Alright, so time dilation is real, but it's subtle. We're talking nanoseconds, millimeters, fractions of reality too small for the average human to notice. But what if it wasn't? What if time dilation on Earth became obvious, like visible to the naked eye obvious? Imagine this. You're standing at the bottom of the Grand Canyon. Your friend hikes up to the rim 5,000 feet above you. After a week apart, you meet again. And she looks noticeably older. Not emotionally. Physically. Wrinkles. Gray hair. She's literally aged faster just from being higher up. People in high-rise apartments would age quicker than those on the first floor. Tall people would technically have shorter lifespans than their shorter friends. Sorry, basketball players. Every airline passenger. Fast-forwarding through time, one cross-country flight at a time. Jet lag. Try jet aging. Your smartwatch might come with a new feature, time drift mode. It tells you how much real time you've gained or lost depending on your elevation and speed. Suddenly, choosing a penthouse suite isn't about a view, it's about staying young. Sports would get weird too. Imagine Olympic rules requiring runners to stay under 6 feet tall because taller sprinters burn time faster, or marathoners running underground to preserve youth. And think about insurance companies. How many stairs do you climb at a quote becomes a question on your premium form. Live in the Rockies? That'll cost you. Live in a basement? Discount unlocked. In a world where time dilation is exaggerated, our relationship with gravity, motion, and even geography would totally shift. Elevators become age machines. Bikes become time portals. And walking your dog uphill? That's a bold, time-consuming choice. Welcome to Earth, where time doesn't just fly, it climbs. Part 4. Real-world uses and wild scientific discoveries. So, time dilation isn't just a cosmic curiosity, it's a tool, a discovery engine, and yes, even the reason your GPS doesn't send you to a lake when you asked for pizza. Let's start with that GPS. Those satellites orbit Earth at over 8,700 miles per hour and sit about 12,550 miles above us. Because of their speed and distance from Earth's gravity, they experience time dilation on both fronts, special and general relativity. If we didn't correct their internal clocks, your phone could be off by up to 6 miles every single day. Good luck finding your favorite taco truck like that. But we're not stopping with satellites. Scientists are now using atomic clocks so precise, they can detect time dilation by lifting one clock just a third of an inch. That's like noticing your hair aged faster than your scalp. At Fermilab, researchers are working on a project called Magis 100 that uses free-falling atoms, atoms skydiving through a vacuum to measure tiny shifts in time. Think of it as quantum Parker, revealing gravity's fingerprints on time itself. Meanwhile, physicists have built interferometers, fancy instruments that spit and bounce light to detect changes in time down to the trillionth of a second. These tools are helping us hunt for gravitational waves, dark matter, and maybe even new dimensions hiding just beneath reality's surface. And guess what? These discoveries aren't just cool, they're redefining how we measure time. By 2030, the official second may be based on optical clocks that can detect time dilation at the human scale. So the next time someone says every second counts, quote, remember, science is literally counting it faster, deeper, and weirder than ever. Part 5. Does time dilation affect biology? Okay, so time dilation messes with satellites, atoms, and your GPS. But here's the real question. Does it mess with you? Absolutely. Time dilation doesn't just affect clocks, it affects everything, including your body. Let's break it down. Your cells tick to their own biological rhythm. Heartbeats, brain signals, cell division, they all march to the beat of time. But if time is moving slow for you, say, you're living at sea level, while your twin lives in the mountains, then you are literally aging slower. And it's measurable. Not in years, but in nanoseconds. Still, it's enough that scientists have confirmed. Your head is older than your feet just because it's farther from the center of Earth's gravity. Taller people, congrats. You're time travelers. Just very, very slow ones. Now imagine astronauts. Living months in low Earth orbit, they return to find Earth has aged ever so slightly faster than they have. Space doesn't just change your bones, it tweaks your time. So yes, time dilation affects biology. You're not just made of stardust. You're also made of relativity. Aging, it turns out, isn't just about diet and exercise. It's about where you stand on the planet. or how fast you are moving through space. Final part: what if you could control time dilation? Now imagine this. What if you could control time dilation? Wanna live longer? Head to a deep gravity well and chill. Wanna binge the future? Hop in a ship flying at 99.99% the speed of light and watch centuries flash by in minutes. You wouldn't just be a traveler, you'd be a time sculptor, bending reality with speed and gravity. Forget time machines, you are the machine. But until then, maybe just take the stairs a little less. You know, to conserve your seconds. Because in this universe, time doesn't wait. But sometimes, it slows down.